Alright guys, day 3 of plane geometry. Today we are going to be going over some problems with circles and then looking at some trigonometry with right triangles. Okay, so we're going to start on page 235, and again I'm not going to do this entire page. I really just wanted to start here to make sure we have our formulas down that we need. So with circles, right, if I draw the circle here, I have the center, this is my radius, okay, if I go all the way across, that would be a diameter, and so my big formulas I need to remember. The area is equal to pi r squared. To remember, area would be, you know, this, how much area does this entire circle cover, okay, circumference is 2 pi r, or pi times the diameter, which that would be, you know, what is the distance all the way across, or not across, around the circle, so in the red. So I think the chart is just you filling out, if you have one piece, how do you find the other pieces, and so on. I'm not going to go through all that. So let's jump to page 246, and we'll do some practice problems involving circles. And actually, I'm going to jump down to this middle section here. I want to go over this piece here. Okay, so it says arcs and sectors are proportional to the central angle of a circle. So you can set up some proportions here based on what is given to you. So remember, it's always the part over the whole. So if you have a circle here and they give you an angle, this is called a central angle right here. Okay, so you can set it up where it's the central angle over the entire whole. Remember, all the way around in an angle is in a circle is 360 degrees. Okay, you could also think about an arc length. So back to my picture here, like this piece would be considered an arc length. It's a section of the circumference. So you could do that length over the entire circumference, which is 2 pi r. Last, you can think about areas. So the sector area, this, like, it's kind of like a piece of a pizza or something, that is called a sector. So you could do the area of a sector over the area of the entire circle, which is pi r squared. So if you're given parts of this, you can use a proportion to set up an equation in order to solve. So I'm going to jump back and I'm going to use that strategy in this problem, even though in this one it's not really necessary. I'm going to show you what that means. Okay, so in the figure shown below, the shaded region of the circle with center C has an area of 25 pi. What is the circumference of the circle with center C? Okay, so I'm looking for the circumference here. I know that the area of this shaded part is 25 pi, right? So, a couple things here. I'm going to first set up my proportion to solve for the area of the entire circle. So, I'm going to use my angle. That angle in the middle is 90 degrees. So, I'm going to put 90 over 360 is equal to the area of that sector, 25 pi, over the area of the circle. Okay, so that's my first way. And again, this one, it's pretty obvious that it's just a fourth of the circle, so you could probably just multiply that by 4 to get 100 pi for the area, and that is what you get when you solve this, right? You could do the cross multiplying, so you get a total area of 100 pi. So this is important because it allows us to find the radius of the circle, which I need to find the circumference. So I know that the formula for area is pi r squared. Okay, so I'm going to replace that with pi r squared equals 100 pi. I can get rid of the pi's, so r squared equals 100, which tells me that the radius, when I take the square root, radius is 10. And so then the question is, what is the circumference of the circle? Circumference is equal to 2 pi r. So 2 times pi times 10 is 20 pi, which is C. Okay, good. Next one, Scotty took a poll at his school asking students for their favorite Gatorade flavor, and then it lists all those percentages. The rest chose other. When Scotty makes a pie chart or pie graph of this information, the central angle for other would measure how many degrees? Okay, so first I'm going to just go ahead and add up all those percentages that they gave me. When I do that, I get 92.5%. So I know that the other category, I need to subtract that from 100, and that's going to be 7.5%. Okay. Now, this is a percentage, right? Not an angle measure. So I need to figure out what my degree is going to be. If the other section accounts for 7.5%, I need to just take that and multiply by the total number of degrees in a circle, which I know is 360. So remember, when I'm finding a percentage, I need to move my decimal place 2 spots to the left. So I'm going to do 0.075 times 360 degrees, which gives me 27 degrees. And that is my answer. Okay. Next one, the figure below shows a circular mirror mounted on a square frame. Each side of the frame has a length of 60 inches, and the mirror is centered on the frame so that the minimum distance between any point on the circumference of the mirror and any edge of the frame is 8 inches. Which of the following is closest to the area in square inches of the mirror? Okay, so this one I don't think is too bad. That 8, that has to be the same, going all the way around here. All of these are 8. Area of a circle is pi r squared, so really I just need to figure out the radius. Now, the mirror, okay, so down here all the way across is 60, but I'm taking 8 away from either side. So really I'm doing 60 minus 16 to give me the diameter of the mirror, which gives me 44. If I cut that in half to find the radius, that would give me 22. So just be careful because I need to square that, right? My answers, they do not leave pi in there. So I do need to go ahead and multiply by that pi, or the 3.14. So 22 squared times 3.14 is 1,519.76. So closest to that would be 1,520. So C. Okay, last one with the circles. In the figure below, square ABCD is inscribed in the circle with center X. If the circle with center X has an area of 50 pi, what is the area of the square ABCD? Okay, so this one I actually think we can do by ballparking. 50 pi, so if I take 50 times that 3.14, I'm getting roughly 157. So the area of the circle is about 157. The area that they're asking is the area of the square. I think that it's obvious that it's taking up over half of the circle, and so I think the only answer that would make sense here has to be F, 100. Okay, I'll go through and show you how that you actually solve this one, but this one I think you could get right just by ballparking. So how you would do this one for real, what they're wanting you to do here, is, so it says that the area of the circle, let's see here, is 50 pi. So area is pi r squared. That's equal to 50 pi. So the radius is going to be the square root of 50. Which, if I simplify that square root, that's 5 root 2, right? If I break this apart, 5 times 10, 5 times 2, I can take the 5 out. So that gives me a radius of 5 root 2. So if I draw this in a nice place here, these are both radii. This is 5 root 2. This is 5 root 2. And that gives us one of our special triangles, right? Let's see. x root 2. And so except it's not, it's this. No, I was right. So this is x root 2. It's just that this is x, right? This is x. This would be x root 2. So then it would be 5 root 2 times root 2. This is root 4, which is just 2. So 5 times 2 is 10. So, and I'm going to do it over here. So each length, each side of this square has to be 10. So then when you multiply 10 times 10, that also gives you 100. Okay, good. So now let's jump to page 249. Okay, so we're going to finish today up doing some trig problems. So I'm going to draw a picture here to help us out. Trig is the study of right triangles. So this only works when you are given a right triangle. Okay, each of these are called legs. The side across from the right angle is called the hypotenuse. It is always the longest side. Hypotenuse. But when we're doing trig, we usually don't just want to call each side the leg. You want to pick one of your angles, one of your inside angles that you're going to be focused on for the problem, and then label your other sides based on that. So a lot of times they use the symbol theta to show which angle you're talking about. So I'm going to be using this angle here. So when I label my sides, I have opposite, adjacent, and hypotenuse. Opposite is always the side across from your angle. Okay. Hypotenuse is always across from the right angle. Adjacent then would be the side touching that angle that you're using. All right. So then the ratios of the sides of your right triangle are called sine, cosine, and tangent. So sine is always equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, they use SOHCAHTOA at the top here to help us remember it, right? Sine would be opposite over hypotenuse, and then so on. Okay, so we'll do a couple problems here. In the figure below, cosine of x equals 24 over 25. What is the value of the sine of y? So just be careful. Notice that they're giving us x, but they're asking about y. Okay, so I'm going to start by using x as my angle here. So the cosine is 24 over 25. Cosine, I know, is adjacent over hypotenuse. So when I'm using x, right, I need to label those in the right spot. Okay, this would be opposite, this would be hypotenuse, this is adjacent. So when I label these, the adjacent is 24, so that's 24. Hypotenuse is 25, so there. Now, normally to find my third side, I could use Pythagorean theorem. But a lot of times on the ACT, because it's multiple choice, you won't have to use it because you can just use your answer choices. So when you look at all the answers, they all use numbers 24, 25, and then the third number is 7. So I know that this length of that third side has to be 7. Okay. So then now I just need to be careful. I'm finding the sine of y. So now I need to go back and actually erase these sides because I'm not focused on x anymore. I'm being asked about y. So I need to relabel my sides based on my new angle. This is still the hypotenuse, but now this is opposite, and this is adjacent. And the question is, what is sine? Sine is opposite over hypotenuse. Opposite here is 24. Hypotenuse is 25. So my answer is 24 over 25, which is F. Okay. And then the last problem here. A boy skateboards down a hill, shown below, that's 50 yards long, and descends at a constant 20-degree angle. What is the vertical height of the hill in yards? So first I'm going to label what I'm looking for, right? The vertical height here. So this one's a little different because I have to set up an equation to solve for x. Okay, So what I'm going to do is I'm going to use this angle because that's the angle they give me, 20 degrees. I'm going to label the sides that I care about here, which are the sides that I'm trying to find or that I have. So across from it here is opposite. This one is across from the right angle, so that's hypotenuse. I don't care about that third side, okay? This also helps me because based on these two sides, I need to figure out which trig function I want to use, sine, cosine, or tangent. So I know that sine uses opposite and hypotenuse. So when I set up my equation, I have to use sine. When you're setting up an equation, it's always sine, it's your trig function of your angle, okay? So sine of 20 degrees is equal to, so we know it's opposite over hypotenuse, so it's going to be x over 50. Since I'm solving for x here, this one isn't too bad. I can just multiply both sides by 50, and that gives me my answer. Okay, 50 times the sine of 20 degrees, and so in this case, that's going to be A. All right, guys, and that is it for today. Thanks.